this problem is where we stopped yesterday, or we finished up with this solving these here, solving this given the 0 using synthetic division. So questions on 24, 25. We're solving the polynomial using synthetic division. So some of the zeros we can find by graphing. We could have graphed this or graphed either one of them and got some of the zeros. Some of them it's not going to be as nice because 2/3 is not going to intersect at a nice point. So we could use the calculator to get it. But synthetic division works a little bit nicer. We divide and we solve. So here we should have 3 solutions. On the one that we did was also a degree 3, so we should have 3. The one that we did yesterday, 25, 2 minus the square root of 5 is 1, 2 plus the square root of 5 is 1, so it gave us 2. We just had to find one more. 26 and 27, write the complex number in standard form. Identify A and B. This really is not going to show up on the test because it's just rewriting standard form. The I squared would make the 6 negative. And we do need to simplify the square root of negative 40. Now the negative would come out as I, leaving us with the square root of 40. At this point here, the 30xs can do this if we want. Square root of 40 is 2 square root of 10. So telling us the square root of negative 40 is 2I squared of 10. So standard form would be negative 6 plus 2I squared of 10. A is our real term, so A is negative 6. B is the real number attached to I, 2 squared of 10. And that's it. It's mainly just converting it into standard form and simplifying. Perform the operations on the given problem. So 28, 13 minus 2I plus negative 5 plus 6I. Bless you. Now, since we're addition, there's no sign in front of our first set of parentheses, so we can drop them. The second one we're adding, so we can really just drop the second set of parentheses as well. Combine like terms. 13 minus 5 is 8. Negative 2 plus 6I is plus 4I. Now the graphing calculator would also let us do this here because we could have just typed this into the graphing calculator and it would have given us our answer. Almost. So for the graphing calculator, we could have done parentheses 13 minus 2I plus negative 5 plus 6I gives us the 8 plus 4I that we just got. Even the next one, 3 plus 2I minus 6 plus 13I is negative 3 minus 11I. Now the same thing can be said of this one here. We have negative 8I times I plus 4I. So we would distribute if we did this by hand. Negative 8I times I is going to be negative 72I. Negative 8I times 4 is going to be negative 32I squared. But I squared is negative 1. So it's going to turn the negative 32 into positive 32, giving us 32 minus 72I. Same exact thing. Now 30, it is possible to do 30 by hand. It takes a minute. When we type the whole thing in, and it tells us it's 585 minus 2,600i. Questions on multiplication? We good with addition, subtraction, multiplication? Yes.
First 29 on the other page. Did you do that? Oh, would you just like, so it's like negative 6 minus 39?
So it's 3 minus 6.
Oh.
Negative 3. 2i minus 13i. Because that's really what we're doing when we distribute the negative. We're subtracting those two. That's why we have to distribute it. Also, these here, the calculator will do them both. Yeah. Now, 31 and 32, write the complex conjugate and then multiply them together. The calculator won't just give you the complex conjugate. But what is the complex conjugate for 7 minus 4i? 7, what? It's going to be 7 and 4i, but something's going to be different. Anybody have a guess? Yeah. Complex conjugate, if a plus bi is a solution, a minus bi. Complex conjugates are these here. So we find the complex conjugate and then multiply them together. Now, one of the things with multiplying complex conjugates together is that we're going to get a single number. I'll do this by hand because you can multiply in the calculator. We've already seen that. 7 times 7 is 49. 7 times 4i is 28i. Negative 4i times 7 is negative 28i. Negative 4i times 4i is going to be negative 16i squared. Now the 28i and negative 28i will cancel. We said I squared is negative 1. So what's negative 1 times negative 16? So again, what I do is I just cross the I squared out and change the sign. If it's 1, I write the 1 in. So all we're left with is 49 plus 16, which is 65. So the two things this problem is looking for is the complex conjugate, so 7 plus 4i, and their product, which is 65, which we could have done the product in the calculator, let the graphing calculator do the work. Now, 1 plus negative square root of negative 8. Before we do anything, we're going to have to simplify that square root of negative 8. Now, the negative is going to have to come out as I, leaving us with square root of 8, which is 2 square root of 2. So really what it's telling us is that the original number is 1 plus 2i square roots of 2, which means the complex conjugate is going to be what? 1 minus 2i square roots of 2. Two. Is 9. So even though we do have I and a radical, when we multiply the conjugates together, everything else simplifies out. Part of the reason we did that was so that we could simplify these rational expressions. And we also learned, well, that's not what I wanted. That the graphing calculator is very nice with any of these operations. So even the division. Remember 33, we just typed it in. It's 60 over 190, or 169 minus 25 over 169. Alpha y equals enter plus 16 I over 2I. Doesn't matter what it is, it will solve these operations for us. Questions on our operations? Questions on anything we've done so far? All right. 35 and 36 didn't get listed on the test this time, but really it's just 4 possible solutions, and then we would do our plus or minus p over q. 35 and 36, find, if possible, the rational zeros of the function. So we're looking for our rational, our fractional zeros, primarily. So irrational I isn't going to be included in this. So even with any of these here, we could always start with graphing x cubed minus 13x plus 12. X to the third minus 13x plus 12. We have 3 spots it crosses. Second table, if we look at the table, again, we're looking for what value of x will make the y value be 0. So where is it 0? 3, 1, and negative 4. Okay. X equals 3. Was it negative 1 and negative 4? Let's 3, 1, 4. Yep, 3, 1, negative 4. Okay, we have those. How many solutions should we have? 3. How many do we have? Do I need to find any more? No. So with any of these here, that's where I'd always start. I'd start with graphing to find our solutions. Because if we only find 2 of the 3, we can use synthetic division to find the third. We can simplify it down to a quadratic and go from there. Find all the real zeros. So for this here, again, I would start with graphing x to the fourth plus 8x to the third plus 14x squared minus 17x minus 42. We see it does cross the x-axis in several places. We have negative 3 and negative 2. It does cross. And the other places it does cross, we don't have whole numbers. One of the places, or especially looking at the table, we know it crosses the x-axis, is if the y values go from positive to negative or negative to positive. Because the only way they can switch is if it crosses the x-axis. So going from the top, y values, we have 132, 18, negative 6. So somewhere between negative 5 and negative 4 across the x-axis. Negative 6, 0, we hit the x-axis, 0. Negative 18, negative 42, negative 36, 60. And then somewhere between 1 and 2 it crosses again. Because again, we have that change. But we know for certain negative 3 and negative 2. So to find the rest, the first thing we have to do is synthetic division, because each time we divide by a solution, we decrease the degree by 1. 1 for x to the fourth, 8 for x to the third, 14 for x squared, negative 17 for x, and negative 42. Luckily, we do have all of our terms, and the number of terms for synthetic division will always be 1 more than the degree. Here the degree is 4, so we should have 5 terms going across the top for synthetic division, which we do have. Yes? Okay. What do we want to do first, -2 or -3? So we'll do our synthetic division. -3 times 1 is -3. Add straight down. 8 plus -3 is 5. -3 times 5 is -15. 14 plus -15 is -1. -3 times -1 is 3. -17 plus 3 is -14. And -3 times -14, bless you, will give us +42. So we did it with one of our two solutions. We'll do it with the next one, -2. -2 times 1 is -2. 5 plus -2 is 3. -2 times 3 is -6. -1 plus -6, -7. -2 times -7 is +14. Now that's all the solutions we had. We can go back and look at the graph. Well, at each spot where we had a solution, it crossed the x-axis. That means there's an odd multiplicity. There's an odd number of zeros there. There's not an even, because if it touches the graph but does not cross it, there's an even number of zeros there. So it could show up 2, 4, 6, 8 times. So on these spots, each time it crosses the x-axis, we will have either 1, 3, 5, 7 zeros show up there, the number of zeros that show up there. Now at this point here, we found how many solutions? 2. How many do we have total? 4. So how many are we missing? 2, yes? How many times did it cross the graph here? 4. We found these two right here in the middle, yes? Which means those other two spots it crosses can only have 1, because it crosses in 2 other spots, yes? So where it crosses, so the 2 that cross at nice spots we found, those two values, -2 and -3, yes? The other 2 spots it crosses, we haven't found them. But there's 2 of them that cross, yes? How many solutions are left? So there's not going to be any repeated. Because there's 2 numbers left, there's 2 spots that cross, each one of those has to show up once. And it's a way for us to know that -2 and -3 aren't going to show up a few more times. It's just, okay, do I need to check these more than once? So what we can do at this point, throw variables back in. Because this is our remainder, 7's, our -7 is our term without x. 3 is our term with x. 1 is our term with x squared. So the last thing we need to solve is this here. Now, for us, this is not factorable. 7's not factors of 7 aren't going to give us 3. So we're going to use the quadratic formula. As we're matching it to our ax squared plus bx plus c. So our first thing is -b. So we'd have negative in our 3, plus or minus the square root of b squared, 3 squared, minus 4, times our a, which is 1, times c, which is -7, all over 2 times a. Now we'll simplify our -3 as well, just going to be -3. On bottom, our 2 times 1 is going to be 2. Now at this point here, we're going to simplify everything inside the radical, our 3 squared minus 4 times 1 times -7. We can grab a calculator. 3 squared minus 4 times 1 times -7 is 37. So it tells us x is equal to -3 plus or minus the square root of 37 over 2. Now at this point here, we'll check to see if the square root of 37 reduces. It does not. So those are our other two solutions with -3 and -2. Questions on this here? Questions on any of this so far? We're ready. We'll look at 38 if y'all want. And again, my first place to start would be right here. -5x cubed plus 7x squared minus 4x minus 2. It does cross the graph 3 times. Let's see where it crosses. Well, the only place it crosses is at 1. Now the number of solutions is 3, so we should have 3 solutions for this here. We'll put 1 inside the box, and across the top we'll have -5, 11, -4, -2. And again, we're going to repeat our process. We're going to multiply and add straight down. So we'll have 1 times -5 is -5. 11 plus -5 is 6. 1 times 6 is going to give us 6. -4 plus 6 is 2. 1 times 2 is 2. And 2 plus -2 give us 0. Now at this point here, we are missing 2 zeros. But because it is a cubic, it started out as a cubic function. What we have left is a quadratic. And since we are and did find a quadratic, just like the last one at this point, we can use the quadratic formula. As long as we can find enough zeros to get the degree down to a degree 2. So with a degree 3, we need to find 1. Degree 4, we need 2. Degree 5, we need 3. We can get it down to a quadratic and use the quadratic formula to solve the rest, as long as it's not factorable. And this is not going to be factorable. Yeah. So we'd have -b, so -6. Plus or minus the square root of our b term squared minus 4 times a times c all over 2a. A is our term in front of x squared. B is our term in front of x, our number in front of x. And c is the number without a variable. Now the few things we'll simplify first, so our -6 is going to be -6. Plus or minus, on bottom we have 2 times -5, which is going to be -10. Inside our radical, we're going to simplify our 6 squared minus 4 times -5 times 2. 6 squared minus 4 times -5 times 2, which is 76. Last thing we need to do is see if we can take the square root of 76. 2 squared of 19. Questions on how we got to this point here? Now there's a few things we can do to simplify it. One of them is to take this negative and distribute it through the top. Part of the purpose for this here is to make the denominator positive. And if we distribute that negative through, the 6 is going to become positive. the plus and minus is going to flip. The minus is going to become plus. The plus is going to become minus. It's a way to get this a little bit nicer so we don't have a negative on top and bottom. Also, all three terms here do share a common factor of 2 we can factor out or simplify out. If we simplify the 2 out of the bottom, the 10 goes from 10 to 5. Our 6, after we factor the 2 out, is going to become 3. And our 2 squared of 19 is just going to be the square root of 19. And with any of these here, just make sure to write out each of the steps. Because if there is something involved or something that happens, you make a mistake in just the simplifying, I will be able to catch it and see what happened from there to there. Questions on any of this here? Questions on anything we've done so far? Any other part of the review that y'all want to look at? Because these here we've looked at already. If we want to look at them again, we can. And 41, 42, all the rest of these are not going to be on the test. Any other questions on any other part of this here? All right.